Hi girls, this is the video for 10a and 10b, probably two videos. Okay, a definition of a logarithm. Okay, a logarithm is a number to a given base is the power or index to which the base is raised to give the number. Oh, that's so scary. So let's look at your formula sheet. So I just clipped this straight off your formula sheet, and it has this little rule here, and it says if I have an exponential, so some number raised to the power of x equals b, that means that x is equal to, okay, that power is equal to log, new thing, base a, so we usually call that a base anyway, base a of b. So we say this part, log base a of b, okay, log base a of b. And this b sometimes is referred to as the argument of the log. It's what it's acting on. And of course, a is the base. Okay, so for the beginning, we just want to use this to rewrite. Okay, so here I'm going to go. The a, I'm in the log, the a is down here, that's the base, so that goes there. Okay, and the x is what it's equal to. So this x in the log equation is always the power. All right, so it goes up there. And then the argument goes on this side. The b, right, goes on that side. So I'm going from one side to the other. These little arrows just mean that that equals that and that equals that. They're equivalent to each other. Okay, is 3 to the 4th 81? Well, I might use my calculator here and just type 3 to the, with that little key, 3 to the 4th, and yeah, it is 81. So I've written it right. Okay, let's try this one. Now this time I'm starting here and going there. So the a is the base, so it's log base 2. Remember that the argument is the thing that's over here in the equals in the exponential form of 32 equals 2 to the 5th. So that means 2 to the 5th is 32. Yeah, that's good. So these are equivalent expressions. One's a log expression, one's an exponential expression. Okay, let's do evaluating logarithms. So if I'm evaluating this, it's kind of hard to do it right now. So I'm going to write it as x. I find that this helps me a lot and it makes it a little bit easier. Now I need that rule, so that rule's in front of you right now. Maybe I can keep it on the screen for a minute. It's in front of you, and I want to use that rule to rewrite this log, because I don't know how to do it, as that. So I'm going to go 2 to the x equals 8. Now I got to remember, and I thought I brought it with me, I did, this little card that we made ages ago, and if you don't have that, you should probably try to make another one. But I know that 8 is 2 cubed. So I go 2 to the x equals 2 to the 3. And once I have these bases the same, we call it equating bases. I'll write it. E-Q-U-A-T-I-N-G, bases. If these bases are equal, then I know that the powers or exponents are equal. All right, let's go over here. When I have zeros here, 1, 2, 3, 4, 5, 6, that means this is log base 10 of 10 to the 6th. Now I can rewrite that. I'm going to make that equal to x. So I get 10 to the x. If this is hard for you, keep looking at that expression, writing it out, equals 10 to the 6th. So x is 6. That's a good one. All right, now for these, we got to remember this idea over here that 1 over 9 is the same as 1 over 3 squared, which is the same as 3 to the negative 2. Okay, that's a really important system there. So I have log base 3 to the negative 2, and that's what's equal to my x. I'm going to put my x there. So I go 3 to the x equals 3 to the negative 2, so x is negative 2. If you're having trouble, again, keep looking back at that rule and pushing yourself through using that rule to change these logs into exponentials. Okay, this one, that is in the tenths place, hundreds place, thousands place. So that's 1 over 1,000, or 1,000 to the negative, did I do that right? I did. 1,000 to the negative 1. So that's log base 10 of 10 to the negative 3. Negative 1, 3 zeros, negative 3 equals x. So go 10 to the x equals 10 to the negative 3, x equals negative 3. There's no doubt that this takes some practice. It It definitely does take practice. Okay, let's just do a couple more. I'm going to use my calculator to do this one. On your calculator, there's a key called log, a key. It means, log base 10. So if I have a log base 10, I can just go log, boom, and I know it's already base 10, just doesn't have it there, of 7. Okay, and that's 0.845 we can write. Okay, 3 decimal places is fine. This has me solving a little bit different. I'm going to use my rule, and my rule again is that if a to the x equals b, then I know that base a of b equals x. Okay, that's my rule from the top. I can't get it on the screen. And so I go, okay, let's see. I've got a log equation, so the a goes here, the x is the power, and that's equal to b. Okay, and I type in 2 to the 6, or I use my card, or I multiply in my head, and I get that 64. All right, now I go here. I'm going to remember this is log base x of 5 to the negative 2. Try to figure that out. 5 to the negative 2. 1 over 25 is 25 to the negative 1. And so that's 5 squared to the negative 1, or 5 to the negative 2. And that equals negative 2. So I get x to the negative 2 equals 5 to the negative 2. So x is equal to 5. Okay, that's good. I'll stop that video there.